Welcome back. In the previous lesson, we talked about the pixels values of an image. Now, in this lesson, we're going to discuss about the most important topic in image processing is resizing the image. Image resizing refers to scaling of images. Scaling comes in handy in many image processing as well as machine learning application. It helps in reducing the number of pixels from an image, and that has several advantages. For example, if at all you want to train the image for an image classification, generally the machine learning model will accept the images of the same size, but it is highly impossible to get all the images of the to get all the training images of the same size. For that, we can use the OpenCV image resizing technique. Using that, we can bring all the images into the same size. This really helps in the machine learning process and also in the deep learning process. OpenCV provides us the several interpolation methods for resizing an image. So here you can see the cv2.interarea, cv2.intercubic and cv2.interlinear. cv2.interarea is a technique particularly used to shrink an image, whereas cv2.intercubic and cv2.interlinear is basically used to zoom an image. So generally the cv2.intercubic is more efficient, but the problem is that it is pretty slow compared to the interlinear. Okay, so these are the three techniques that we actually have in the image resizing in OpenCV. Now let's use the cv2.image resize and try to use all the three interpolation techniques that was there in the OpenCV and resize the image. Let's go back to our Jupyter notebook. Here I go, I'm in the Jupyter notebook, and also I created the one more notebook with the name 03 image resizing. And here is the notebook, which is what I'm having with me. And here I already imported the NumPy and the OpenCV library. Now the next step is what I'm going to do is I need to load the image, and for that image I'm going to show you how to shrink an image and how to enlarge the image. The image that I'm going to take here is from the data, and that is my flying_bird.jpg. And this is what the image that I'm going to consider here. First, let's load the image. So this is my loading image. We already know how to load the image. Let's say it is img equal to cv2.mread. Now provide the path of that. It is from the dot, which means the local, from the data, and just provide the path of the image, which is my flyingbird.jpg. Now let's look at the shape of this image for a while, and also let's print this. And also let's display the image, which is using cv2.mshow, and this is my original image. Now the array is img. Next is cv2.wait key and provide the delay to 0. Next cv2.destroy all windows, which will actually display our image as well as shape of the image. Here we go. This is what my original image, and we are having the 480 rows and 640 columns, which means that the rows is basically represents the height of the image, and the width of the image is basically represents the column. So we have the image of 480 and the width of the image is 640. Okay, now let's consider the image and let's do the two things here. One is enlarging the image, second one is shrinking the image. Let's do that. Press escape to close the window. Okay, and here my idea is that I want to do the two things. One is shrink the image, second one is enlarge the image. So that's what the task I need to perform in this lesson. In order to shrink the image, I'm going to use the enter area technique. In order to enlarge the image, I can use either intercubic or interlinear. Alright, first let's shrink the image. This is my shrinking image. So here I'm going to use the cv2.resize. So this is what the method which will help us to resize the image. And we need to understand the following arguments. The first one is the source, which indicates the source of the image, and second indicates the desize, which is actually the desired width and height of the image. Next is interpolation technique. So if at all you want to shrink the image, we need to provide the enter area. And if at all you want to enlarge the image, you can use intercubic or interlinear. Okay. Now what I'm going to do here is that since I want to shrink the image, I'm going to use the enter area. Now let's shrink the image. So here the source is img. Next, this is the D size. The D size is very important. So what is the size is what actually you're looking for, you need to provide here. For example, D size is going to be the tuple of, always remember one thing, the sequence is width and height. So for the first one, we need to provide the what is the width, and second one is the height. Width is basically represents the columns and height is basically represents the rows. So for the sake of simplicity, I'll write down here is width represents the columns and height represents rows. Okay, the sequence generally we need to provide here is we need to first give the width of the image and second one is the height of the image. So the width of the image I want to shrink, let's say, since here my width of the image is 640, I want to shrink, let's say, to half the size of this, it could be the 320. Next, similarly, the height of the image I want to reduce to half, let's say this is my 240 is what my height of the image. Now provide the interpolation technique, which is this, and that's going to be equal to cvt dot inter area will actually shrink the image. Let's provide that, which is the flag of cvt dot inter area. That's it. So this will actually shrink the image. So let's do that. Let's save that in an argument, image shrink. Okay, so this will actually shrink the image. Similarly, we can also enlarge the image. So the interpolation method is generally used to enlarge the image, which is cvt dot enter cubic and cvt dot enter area, interlinear. These are the two interpolation technique which actually enlarge or zoom our image. Okay, let me create a variable which is in the img underscore zoom. Now let's use the same method, which is the resize. Using that, we can even increase the size of the image, and obviously the first one is img and second one is D size, is what is the size of the image you want to increase. So let's say I want to double the image. My original image is with the width of 640. I want to double the image with 1280. So make sure it is always good practice to get the aspect ratio to be same. Now in order to, if you double the 480, and that's going to be equal to 960. Okay, now the interpolation technique is you can use either cvt dot enter cubic, or you can use either enter area. So even this is also fine, you can use either way. Intercubic is usually the bit slow but more efficient. Okay, now with this we know how to shrink the image, we know how to enlarge the image. Now let's execute this and success, and we have successfully shrink our image, and that's saved in the variable img underscore shrink, and we also enlarge the image, which is img underscore zoom. Cool. Now let's display this. First let's display the shape of the image, img underscore shrink dot shape, and also let me also display the shape of the zoom. So here you go, this is what the height of the image for the shrink is 240 by 320, whereas for this is 960 by 1280, which is what the desired thing which we want. Now let's display this. I'll copy this portion. Now let's display the shrink, which is cvt dot mshow. This is my shrink, and the image or matrix is img underscore shrink. Next is cvt dot mshow, and the matrix, this is basically the window name is zoom, and the matrix variable is img underscore zoom. Let's execute this. Oh, we got an error. Yeah, this is basically the mshow. All right, now let's execute again. Okay, let's re-execute it again. Here we go. So this is my original image. This is my shrink image. This half of this, and we have the zoom image. This is the zoom image, which is the double the size of my original image. So this is shrink. I can put it here. This is really nice. All right, so this is my original image, this is my shrinked image, and this is my zooming image. It's really pretty cool, right? You can see that is almost the loss is nearly negligible. So this is how we can shrink, zoom our image using OpenCV Resize. In the next lesson, we will talk more on this. Until then, happy learning.